Hello students, you are welcome to the fifth session of Unit 4. In this session, we'll be looking at barriers to curriculum development. Let's look at the session objectives. By the end of the session, you should be able to explain how value, power, practical and psychological barriers affect the school mathematics curriculum. In our previous session, we talked about other pressures that influence school curriculum, and we looked at societal and political, subject-based, educational, and rewards of innovation pressures that influence curriculum development. There are four main barriers to curriculum development, and these are value barriers, power barriers, practical barriers, and psychological barriers. We shall take them one by one and look at what each of them stands for. Let's look at value barriers. Different people have different ideologies, interests, and so on. So what one values will influence, the way he or she sees curriculum development. So sources of values may come from political, religious, educational, and social background. This significantly affects the way in which people react to suggested innovation. So if you see things differently from another person's perspective, then it will influence the way you react when there's a suggested innovation in the curriculum development. Values affect the way we view and teach mathematics, as we know already, and also affect the way we see school mathematics in general. So what that we are saying is that the way what we value, which comes from political, religious, educational, and social background, may influence the way we see issues related to curriculum development. Another barrier to curriculum development is power. And what do we mean by power barriers? Significant innovations are often accompanied by shifts in the balance of power. People may oppose to newly established curriculum development centers and institutions. So when there's a balance of power, then innovations are often accompanied by that, and people may oppose to new things. Now, this balance of power may be away from the teacher, it comes from the teacher, central authority, etc. And all these things constitute that universities have fought and are fighting to retain their influence on the school curriculum. So as we know, universities have fought to have to have influence on school curriculum, and they are still fighting to retain their influence on that. Parents, students, and employers wish to exercise more power. So everybody is fighting for some sort of power to be able to have a say in curriculum development, and all these things can be classified as power barriers. Practical barriers. At times, it is necessary to revise the school mathematics curriculum. The use of graphing calculators, for instance, may pose these challenges. Few, if any, teachers know about how to use the graphing calculators. So all these things are practicality. So we want to change the school curriculum. There's a need to do that. But are we ready? Do we have any practical barriers? And for example, if you take the introduction of graphing calculators, some barriers are the number of teachers, or if any at all knows how to use the graphing calculator himself before teaching students. And then another barrier is it would be extremely expensive. That should be expensive, and perhaps logistically impossible to implement. So sometimes a change or innovation becomes very expensive, and in terms of logistics, it may be impossible for us to implement. So graphing calculators, for example, can our students afford it? Can the government supply it freely to the students? All these things are some barriers that may, influence curriculum development. In-service programs to remedy the deficiency. So, are we able to organize in-service programs to remedy the deficiencies that we encounter as a result of introducing graphing calculators? And additional money and manpower needed to produce the necessary textbooks. So definitely, if we introduce graphing calculators, they must be integrated into the textbook. And are we able to do that? All these things are barriers. New forms of examination will have to be introduced. So since we are now using graphic calculators, then there is a need for new forms of examination. All these things are barriers. And then to make room for this change, some traditional topics would have to be omitted. So all these barriers will come as a result of, for instance, introducing graphing calculators. And all these things are considered as practical barriers to curriculum development. Let's look at psychological barriers. People are happiest doing what they are used to doing. And I know how to do this. It has been with me since. So I'm happy doing it. Therefore, we find it difficult to adjust to innovations. When you are used to doing something in a particular way, there is difficulty when you have to adjust to innovations. So people see the known as secured, while they see innovation as taking a risk. So if you want to, innovate, you see it as taking a risk because this is how we used to do it. So why don't we continue doing it in that line? Why do we have to change the way we do things? We may fail. So people see it that way psychologically. So one of these barriers, perhaps the most difficult, is the previous unsuccessful innovation. So if probably a country has tried it and it has not been successful, it serves as a barrier, and other countries trying the same innovation may use those who have failed as examples, and that may create fear in the system. And then incentives. When people can see what they stand to gain, they can easily accept to change their behavior. So psychologically, incentives also play a critical role, and it's a barrier to curriculum development. So when people don't see readily what they can gain from something, and you ask them to innovate, they can't do it, and it is difficult to accept that change in behavior. We have come to the end of the 5th session, and as usual, I'll leave you with these questions. You explain the following barriers to the development of the school mathematics curriculum, as you can see on the screen. So try your hands on these questions